remembers the process that engineers use when they're trying to solve a problem? Poppy?
The engineering design process.
The engineering design process. And what was the first step in the engineering design process?
Ask.
Ask. That's right. What earth materials were we learning about yesterday?
Soil, sand, and clay.
Soil, sand, and clay. And we were looking at specific properties of soil, sand, and clay. What were those properties?
Strength and stickiness.
Strength and stickiness. That's exactly right. So we already started asking some questions. So I want you to think about what would make a good mortar. What would not make a good mortar?
Yeah, I think sand and clay, actually. It's like the clay would stick it together, but there would be like an outer layer of sand. Soil had the most check marks, and clay is like a very good material for sticking things together. I was in the school, but I wasn't in the school because it's really destroyed. That's all year. Why? I think that's all year. Same here.
I mean, no matter if it like cracks when it dries, it can still make a great mortar.
I don't want your mortar to crack, though.
Then?
Right. Because if it cracks, it could potentially fall.
The clay cracked and it didn't fall.
Yes, that's because it was only two tiles. But what if it didn't? But a gigantic wall.
I feel like we've been asking a lot of questions over the last couple days about the materials that we're going to use. So guess what? It's time to move to the next step of the engineering design process. What's the next step of the engineering design process? Addie?
Imagine.
Imagine. You guys will each get one of these papers. So each of you individually, you're all going to get a chance to imagine what you would like your mortar to look like. And put your hands on your head so that I know you're finished. All of you guys have gotten an idea to use what we've learned about these earth materials, about their properties, and you come up with some ideas of your own about the mortar that you might want to make. Now we have to do some negotiation because, like I talked about yesterday, engineers rarely work alone, right? They usually work together because everybody has different strengths and weaknesses. On this sheet, you're going to write the mortar mixture that you decide upon together.
We wouldn't want to use sand because right when you get it wet and then you stick stuff together, it will, after like a couple of hours, the sand will dry and then it all just fall apart. Maybe we should do 2 soils instead? Well, there weren't that many cracks. Yeah, but there still was quite a few. I think clay, soil. Do you think clay, soil, or soil, and clay? Clay had a lot of cracks, so I think a lot of soil will help.
Look, I'm going to bring around a couple rocks for you to look at your tables. I want you to think about and draw underneath your design number 1 mortar how you're going to arrange these in your wall. Have we planned our walls? Yes. We all did drawings. Those are your plans. Where are we then? Okay, so this is what's going to happen. You're going to be building your wall on this cardboard circle. You will need to come here to the materials store with your plan. There is a bucket here of wet soil, a bucket of wet clay, and a bucket of wet sand. So once you have the 3 materials, you need to stir them up with your popsicle stick, and then you can use the popsicle stick to spread on the rocks. You guys look ready to go. You can go to the material store together. 2 scoops of soil, and you can go get a scoop of clay from Miss Hatch. Take your plan.
Whoa.
Is that what you thought it would look like when you mixed all 3 together?
No.
No? Why not?
I thought it'd be more like clay.
I have to admit, I'm starting to love science even more than I did before. You didn't like science before? Nope.
We need some mortar right here. Can you spread it along there? That's 5. 5 inches. No, wait, we need to measure it. 6 inches. Okay, I'll take it over.
I'll be.
Don't? That's bad. Dude, that's bad.
Can I have anybody share their reflection? Did you guys feel that that was harder, easier, or about what you expected it to be?
It was kind of harder than I expected because I didn't know that our mortar would be that slimy with all the soil that we use. Maybe we should have gotten more clay instead of more soil.
Good observations. How are we going to test our mortars to determine whether they're strong enough?
You could tap on the wall.
With what?
Your finger.
I like Addie's idea, but I want to figure out how we could do that in a scientific way such that we could make sure it's consistent.
You could use a pencil.
We could use a pencil, but it's a person behind the pencil, right? How else could we do this?
We could build something.
Like what?
We could take a piece of wood and then add a little pole onto it with string and then use a fan or something to hook we would hook the pencil up to the string that's on the pole, and then you could use a fan or a hairdryer to push the pencil to poke it.
So she said to tie a string to a stick and have a fan so the pencil would hit the wall. So we're going to test our walls to the point of failure, and we're going to use a method very, very similar to the one you guys just came up with. This stick, if you guys can see, has a transparency tape to it with 4 different levels. But what we will do is hold it up so that the string matches the level, and then we'll swing it against your wall. Why would we want to break your walls apart?
To test to see how strong the mortar is.
Right. Engineers all the time test things. It's called testing to the point of failure. You want to know how far it can hold before it breaks apart. Are you guys excited to test your designs tomorrow? Yeah. Me too. All right, guys. Today's the big day, right? We get to test your designs. You guys ready? Yeah. 3, 2, 1. All right, here we go to number 2. What did you notice?
That the 2 pieces on the top kind of fell off.
Let's see if we can wreck it more, huh? Level 3, here we go. Ready?
3, 2.
I'll do one more to level 4. Seems like if it hits it flies. What do you notice aside from the fact that some rocks fell off?
There's a lot of mortar on the rocks, but not in between in the gap, so that might have been why it fell over, because there was too much space in between.
What kind of mortar did you use?
All 3 of them.
You used 1 scoop of each. So what would you change to if you were going to change?
Clay, sand, and another clay.
2 clay and 1 sand. Now this is Anna and Michael.
Okay.
What do you 2 notice about your wall?
It has cracks in it.
It has cracks in the mortar. What else? It has some holes too. 1, 2, 3. What'd you notice?
Nothing happened.
I saw a tiny bit of mortar go flying, but not a lot. 1, 2, 3. Again, it was just the top that went down though. 1, 2, 3. Let's try 3 one more time. Total destruction. So, ladies and gentlemen, overall, I was really impressed with how well your creations did against the wrecking ball. You guys got to talk as a team about what your approach is going to be to improving the design.
We need more mortar on the top. I think we could probably stack it like that and change the ripple and change, not make it round. I don't play soil. No, I'll and make it skinny ones you can save for like putting on top like that.
Okay, ladies and gentlemen, a few teams are finishing with their last rocks. I'd like everyone else to be coming back to their seats. So tomorrow we'll come in and we'll test your improved designs. I'm going to take some observations of it first. What do you notice?
A lot of cracks.
A lot of cracks. 1, 2, 3. Level 2. 1, 2, 3. A little piece of mortar flew, but not so bad. All right, level 3. 1, 2, 3. What was your mortar recipe?
Clay, clay, and soil.
Clay, clay, and soil. All right. Wow. Is this soil, clay? Is that what you guys did? Yep. And I remember that the first time you guys did your wall, you stacked. Did you change that approach this time with your rocks? What did you do? How did you go about stacking them?
We smushed them together and we didn't actually stack them.
Oh, I saw
A little bit of mortar flew on too.
on this side.
Number 3.
It's gonna fall
A little bit of mortar came down. Number 4. Second time on number 4. Oh. Hey, but that was improvement. Michael and Anna, I'm proud of you guys because I do think you improved your design quite a bit. I want to know what you guys think about this experience. Who can remind me, what is an engineer? Quinn.
Someone who fixes and solves problems.
Someone who fixes and solves problems. Using what, Addie?
The EDP, also known as the engineer design process.
Amelia, what else does an engineer use to solve problems? Their knowledge of math and science. That's right. And sometimes, like Joey said, they use technologies. Sometimes they create technologies. I'm curious which part of the design process you guys found the most challenging.
You had to build it in a certain amount of time.
So you found the time constraints around creating challenging? Okay. Anna?
Trying to put the rocks together.
So which step in the engineering design process is that? Create. Okay, so 2 people in here. Raise your hand if you agree with Charlotte and Anna that the create step was the hardest part. Interesting, interesting. How many of you enjoyed this experience? Well, I had a great time with you guys this week, and I look forward to doing more engineering with you guys. Today, when we were reflecting on the experience, a lot of kids, like half the class, found the creating step to be the hardest part. And I didn't talk to all of them about what they enjoyed the most, but several of them, it was both the hardest part of the process and the most enjoyable part of the process for them. I think they thought it was going to be easier than it was.